This is the Building Automation Monthly Podcast with Phil Zito, episode 165. Hey folks, Phil Zito here, and welcome to episode 165 of the Building Automation Monthly Podcast. In this episode, we are going to be covering Modbus, which is one of the 3 building automation protocols that you should know if you are working in the building automation industry. The other 2 are LAN and BACnet. And in this episode, we're going to do an overview of Modbus. We're going to talk about what it is, how it's structured, and kind of a little bit of everything around the Modbus protocol. This is a protocol that is commonly utilized to interface with conveyance systems, so escalators, elevators, etc., as well as power systems, so any power monitoring. We will typically utilize Modbus to interface with those systems. It's also a protocol that has a prevalence in the industrial controls world as well, but we're not going to be focusing on that. Before I dive into Modbus, I want to let you know that this week's episode is sponsored by our Building Automation Protocol Bootcamp. If you want to learn more about these protocols, these podcast episodes are literally just the tip of the iceberg. There's so much more to know about these protocols, and we discuss all about the 3 protocols, Modbus, BACnet, and LAN. Everything you need to know as a building automation professional, we teach you in the BAS Protocols Bootcamp. So you can check that out by going to buildingautomationmonthly.com/165. Scroll down to the BAS Protocols icon and logo, click on that, and you can purchase the course. So with that being said, what is Modbus? Well, as I mentioned, Modbus is a protocol. Now, just to recap, protocols are sets of rules and functionality that ensure that 2 systems can communicate with one another. So BACnet, LAN, Modbus, they all standardize how 2 devices or more than 2 devices can communicate with one another. Now, Modbus is a relatively simple protocol, and in order for us to really understand much of what's going to be covered in this episode, we need to get some terminology out of the way. Now, normally I'm not someone who sits here and recites terms. I don't sit and spend entire episodes going through terminology, but with Modbus, it's important that we understand these 3 terms. First of which is called the ADU. Now, the ADU is the Application Data Unit. And for Modbus, the ADU is going to encompass the PDU, which is the Protocol Data Unit. So the ADU is going to be handling things like error checking. It's going to be conveying maybe additional addresses if you're sending bulk messages, which most of you are not. Most of you are going to be doing single messages. You're not going to be doing bulk messages. Now, the PDU is where most of the stuff that you're going to care about is going to happen. This is where the function codes are going to be. This is where the data is going to be. And speaking of function codes are telling the Modbus server what to do in response to Modbus requests. Now, as we've heard in previous episodes, servers, they exist with this kind of response request methodology, right? So you send a request to a server, and that server responds to that request. In the case of web servers, you send a request for a web page, and the server responds with the actual HTML for that web page. Well, it's pretty much the same thing with Modbus, with BACnet, with LAN. They being the devices, request, maybe a write property or read property or whatever. And in response, the server provides that response. Okay. So what is Modbus? Well, Modbus quite simply is a client-server protocol, and it functions primarily at the application layer. So as we recall, we have layers 1 through 7, and while Modbus definitely does utilize layers 1 through 7, I mean, after all, it's RS-485, RS-232, or TCP, so Modbus does exist and use communication across multiple layers, but a lot of what happens at the application layer. So Modbus clients, basically what happens is they submit a request to the Modbus server, and the server responds to these requests. And how it knows to do that is based on that function code we just discussed in the protocol data unit, all right? So far, we've got this server, and we've got this device, and this device is requesting something, and the server responds. Now, how does the server know how to respond? Based on the function code that's in the PDU. Now, the server responds to the client with an appropriate function code and any data if required. This is very similar to the BACnet read and write property services. So if you understand BACnet read and write property services, and you understand how you do a read and you issue that read and then you get a response, or you issue that write and you get a response, well, this is very similar to that. So as I mentioned, Modbus, it's going to be transferring these messages, these ADUs that contain PDUs from client to server, and they're handled on this whole kind of request response. Now, there's two stacks when we're utilizing Modbus. We're utilizing TCP IP or we're utilizing RS-45232. And actually, the versions of Modbus that do this are quite different. So you have Modbus TCP, or Transmission Control Protocol, which is utilizing IP addressing and is using TCP for the connections between the clients and servers. And then you have Modbus RTU, right? And RTU is using 45 and 232. So there's a big difference between these two. It's something we dive into in great detail in our course. Now, excuse me, I'm just getting over a cold, and man, I've had this cold forever. It just won't go away. It's crazy. So as I was saying, the Modbus ADU, and here's what I want you to kind of picture here, right? Is it has a field for additional addresses. If you've ever seen like network packets and you've seen the different fields, time to live, things like that, source and destination MAC, etc., then you'll know what I mean by fields. So it's actually a field inside a message. And so the ADU contains 4 fields, right? It contains the additional addresses, as I mentioned, the function codes, the data, and then error checking. Now, error checking is good because it makes sure that the message isn't corrupted. Not such a big deal with IP, but definitely a big deal when you're dealing with serial networks. IP messages definitely can get corrupted, but they get corrupted, in my experience, less than actual field level networks, which is RS-232 or RS-485. Now, as I mentioned, the ADU contains the PDU, and the PDU simply contains the function and the data. So essentially, what is going to happen? This is like how Modbus works, right? And there's a reason I'm spending so much time on this, because I tend to find that in our field, we tend to greatly understand how BACnet works. We really poorly understand how LAN works. And then we think we understand how Modbus works. But yet, if you look at the protocols, I mean, LAN was standing with its network database issues. I mean, LAN can be a bear to set up, but once you get it set up, it's pretty easy to work with. Modbus is one of those things that a lot of folks tend to really struggle with. And I find it's one, because they don't understand the data types that Modbus supports. They also don't understand what they mean, and they don't understand how messaging occurs. So we're going to spend a fair amount of time in this episode on messaging, and then we're also going to look in this episode at the data types. So we're going to kind of focus in on those things, because if you understand those, then when you're doing Wireshark trying to troubleshoot why is my Modbus network not working, it's going to make a lot more sense. So when a Modbus client, and notice the words I'm using here, Modbus client requests actions from a Modbus server. So the client requests the actions from the server. And the Modbus client forms the ADU and PDU. And then the ADU will contain whatever it needs to, error checking if needed, additional addresses if needed. But as I said, typically does not contain those for what we do. Now, the PDU is going to contain the function code and any data. I'm not going to get into all the function codes. You can Google the Modbus standard and look up the function codes. It's really easy to find. But just realize the client is forming the function code. So that's your first point of troubleshooting, is to make sure that the client is actually forming the function code correctly, and that that function code is actually calling to the right register or coil, which don't worry if you don't know what register or coil means just yet, because we're going to discuss that later on in the episode. So the server then processes this ADU and then generates its own ADU response with the appropriate function code and data. So for example, if Modbus said, hey, I want to do the backnet equivalent of reading a property, the client would instantiate that ADU and PDU, send it to the server. Server would then execute that and would respond with the read property result in its own PDU, which is contained in its own ADU. Do you get that? That's really important that you understand that, because that's your first point of troubleshooting, is to make sure that these messages are actually coming through clearly. Now, Modbus is not encrypted. So when you need to go in Wireshark and actually read PDUs and ADUs and all that jazz, you can actually do that. All right. So what about errors, right? I mentioned errors and I talk about errors all just a little bit, right? I say that there's this error checking. Well, if a server experiences error checking, meaning the message goes out one way and comes back the wrong way, the error checking, which I'm not going to get into in this episode, basically says an error occurred, then the server will actually go and issue an exception code. And that is contained in the PDU. Now, this is another really important thing. If you're taking notes right now, it's really important that you took notes on how the client forms its ADU and how the server responds its ADU, and then how the server handles notice I'm saying the server handles error checking. And then the server sends the exception code in the PDU. That's important because this exception code is going to give you an idea what to do when you're actually troubleshooting. Okay? Really important. Now, there's a couple different types of PDUs, right? As I mentioned, there's request PDUs. These are issued by the client and they're a function, right? They have a function that they go and issue. And then the response PDU, and this is issued by the server and it's a response. And there's actually two types of response PDUs you can have. You can have your response PDU and your exception response. Now, we already know what an exception response is because I talked through it just a second ago. So it's really important that you understand that. Now, we read data and we write data, but we do it from what? And this is what throws a lot of people off. If they do get the Modbus kind of read and write and server and client, if they do understand that, this is where they mess up. There are 4 object types: discrete inputs, coils, input registers, and output registers. Okay? Now, discrete inputs. So actually, before I do this, I want to talk about something that I've covered in previous episodes, but I just want to make sure you understand. There's this thing called a bit in the computer, right? And a bit is a single signal across a wire. Wow, that is hard to say. Wow, I'm not even going to try to say it again. Oh my gosh, 3 times fast, right? Okay, so a bit is either on or off. It's a 1 or 0. It's a binary state. When you combine these bits together, that makes data. So when you have discrete inputs and coils, those are single bit objects. They can either be a 1 or a 0. Now, input registers are 16-bit objects, meaning they have 16 bits, just like output registers. So when you see register, that's 16-bit. Now, I'm not going to get into 32-bit and 64-bit and all the kind of craziness. I know there's manufacturers out there nowadays who have 32-bit and 64-bit. Actually, I will get into that. I will tell you a little bit about that after I go through these. As I think about it, you know what? We're good on time. I got time to tell you about that. All right, but as I was saying, we have these single bits and we have 16 bits. Now, if you're still confused by the concept of a bit, it's really simple. If you think about when you are setting a MAC address on a physical field controller and you're flipping that dip switch to either an on or off state, that is a bit. When you're looking at an IP address and you're trying to calculate your subnets and trying to calculate your hosts and you're doing subnet math, those are bits, right? Because an IP address is 32 bits, 32 optional on or off switches, essentially. Now, the thing is, with discrete inputs and input registers, they only support read functionality. So this is one of the first areas that folks start to mess up, is they go and try to write to read-only functional points. So input registers and discrete inputs, you can't write to those. They are read-only. The second area I find folks tend to mess up is that they will go and only read, for example, as I mentioned, there's 32 bits and 64-bit objects. They may only go and read the first 16 bits of a 32-bit object. What they don't know is that in order to get results from an object, let's just make something up like KVA or something, right? They want to get KVA, but the KVA point on that Schneider meter is 32 bits and it's not 16 bits. I'm making this up. So if you're like, no, Schneider meters only have 8 bits, Phil, you're wrong. I'm making this example up. Okay. All right, good. I get a lot of emails where folks, for some reason, don't register when I say I'm making the example up. All right. So as I mentioned, you've got 16 bits, but the object itself is 32 bits. In that case, you actually have to read 2 registers. But people only read 1 register, and then they wonder why they're getting these funky values if they don't get an error. It's because they're not reading both registers. So oftentimes, depending on your BAS, you'll have to read both registers, and then you'll have to combine the values, or you may have to do some weird, funky scripting. It just depends on your building automation system. Now, as I mentioned, discrete inputs and input registers support read functionality only. You can tell how important this is by the fact that I've repeated it about 4 times now. All right, now coils are single-bit objects that support read and write functionality, as are output registers. Output registers also support read and write functionality, and they're 16-bit objects. So when you want to write to an object, you need to know the right type, and you also need to know how many bits. And sometimes you may have to write to 32-bit objects, in which case you've got to write to 2 registers. All right, I hope this is making sense because it's really extremely important that you understand these 4 objects. Because if you don't get it, this is the second really big area that folks make mistakes on. All right. Now, Modbus has addressing, right? So Modbus addresses are logical addresses and physical addresses. Okay. So physical addresses, Modbus, right? RTU, you're going to have a different type of address than TCP, which is IT or IP, right? Because RTU is a serial network, TCP is an IP network. I'm not going to get into addressing. It's a very complex topic, especially for logical addressing. That's an even more complex topic. It's something we cover in our course in great detail, but it's something that is complex. What I do recommend, if you are trying to figure that out, I will include a link on buildingautomationmonthly.com/165, is you do like I did and you read the entire Modbus specification. Like I said, if you don't want to read the entire specification, we summarize it all in our course. But if you're like me and you do, I'm going to link to it and you can actually go read the entire specification. I think it'll really help you out going and reading it. So the last thing I'm going to leave you with here is when you're working with Modbus, you need to understand that you can only have 1 server. Everything else is a client. If you try to set up multiple servers, you will get issues. Because remember, the server in Modbus is what handles the request and the response cycle. So if you have multiple servers on the same network for Modbus, that will cause issues. So as I look back at my Modbus experience and helping people troubleshoot Modbus, and I look at what kind of things they really got hung up on, one was not understanding that request response, and error cycle. 2, not understanding the difference between coils and registers and inputs and outputs, read-onlys and read and writes. And 3 was not understanding that servers, you can only have one Modbus server per Modbus network. It's really important that you understand that, because if you don't, you're really going to hose some stuff up. So there you have it, folks. That's Modbus for you. If you have questions about Modbus, I really encourage you to go to buildingautomationmonthly.com/165 and go and ask your questions in the discussion board. If you're listening to this on YouTube, then by all means, just put it in the comments. And I also encourage you, if you have not done so, leave a review on iTunes for the podcast. It really, really helps get more eyeballs on the podcast. And that just benefits our entire industry. So with that being said, thanks so much for listening to today's podcast episode. I really appreciate it. I hope you all had a good Memorial Day weekend, and I look forward to talking to you all again in next week's episode. Until then, take care.